All right, to complete the table, population growth, we don't know the K, the growth rate. We do know the starting amount and the projected amount. So in 2006, the population was 48.7. The projected 2044 population is 30.1. That means the population went down. So the growth rate should be negative. And population is it's not continuously compounding, but it's so close to continuously compounding that we use that formula. So really it's going to be this APERT formula, because it's a population which is continuously compounding. Okay, 2044, that's going to be the final amount. It's going to be the A. 48.7 is the starting amount. That's the P. And the interest, the rate, it normally stands for interest rate. In this case, it's growth rate. We'll write that as K. Is going to be multiplied by the T in time. The time is from 2006 up to 2044, which is going to be 2044 minus 2006. It's going to be 38 years. So T is 38. All we have to do now is solve this. So divide out the 48.7, I mean. E to the 38K. Now we can take the logarithm of both sides, the natural log, because that cancels with the E, giving us 38K equals natural log of 30.1 over 48.7, and then divide out 38, giving us just K, which gives us natural log 30.1 divided by 48.7, divide that by 38. Negative, which is good. And it says round K to 4 decimal places. So we have negative 0.0127. And that's correct. Last problem. Logistic growth function at the right describes the number of people who have become ill with influenza T weeks after its initial outbreak. Okay. How many people became ill with the flu when the epidemic began? That's when T equals 0. Well, when T equals 0, E of T becomes 1, because E to the power of 0 is 1. And we have 1 times 5200. That becomes 1 plus 5200, so it's 5201. We have 109,000 divided by 5201. Putting that in a calculator, 109,000 divided by 5201. That gives us 20.957, round to the nearest number of people. So it has to be a whole number because it's a person. That should be 21. 21 people were initially infected. Now, T is in weeks. That's important to note here. As it says 4 weeks, that means T equals 4. Make sure, so the first one, just to write it down, is f of 0, 109,000 over 1 plus e to the negative 0. This is just 1, and 1 times 5200 is 5200. Then 5200 plus 1, that becomes just 109, which is approximately equal to 21. The next one is f of 4. So we have 1 plus 5200 e to the negative 4. And this one, really, you just got to type in a calculator. The powers of e, the numbers of e, are not very easy to calculate. E to the 0 is the only one that's easy to calculate because that's going to always be 1. But every other number is going to be hard. So just plug it in a calculator. E to the power of negative 4. I'm getting 0.1133 rounded to the nearest person. Okay, the limiting size of the infected population is what? That's the same thing as thinking as t goes on towards infinity. So if you plug larger and larger values into here, we could do that. We could like type in, like plug in 1,000 weeks, plug in, you know, a bunch of zeros, like a billion or whatever. We could do that and we'll see it. We'll actually see the number come out. But you can also think that e to the power of negative t, this function looks like this. So what happens as e to the power of t gets larger and larger? What happens as t increases? That means that e to the power of negative t goes to 0. So really, this thing just goes to 0. So we can think of this like this. F of t equals 109 e to the negative t. This thing just goes to 0. And we have 5,200 times 0, which is 0, giving us 109,000 over 1, which is 109,000. Just the number on top. And I'm guessing that's the population number, right? You can't have more sick people than you have people. So that should be the limiting value, and it's correct.